and I forgot to, is that this ammonia is combined into making urea. And the urea can be filtered and excreted, but high levels of urea, if you're doing an awful lot of this, you get lots of ammonia, lots of urea. Urea will denature proteins, and it also causes what? Gout. So this can be a complication of its own. Now, if you're in balance, and what you're really doing is you're burning a lot of, or a significant amount of triglycerides each day, you know, and you have some ketones in your breath, in your urine, that's probably not the end of the world, as long as you watch, you know, your vitamin levels and so forth. Because my concern would be excess protein with that sort of diet, because you are, you know, let's face it, our ancestors were probably fruit eaters, you know, much as anything. So now we're going completely away from that in this Atkins system. So something to consider there. But I personally like food, so you know that. But I don't think that, you know, I think it's the worst is the supersized soft drinks, you know, and some of those kinds of sources, the donuts, the refined sources of carbohydrate that we need to watch out for in our fast food culture. Have you seen that movie Supersized?
Isn't that amazing?
That's a classic. And the author actually did it. He supersized himself as a target. He did an experiment on himself. Yes?
Now, when the protein is going to the protein synthesis is anabolic.
Anabolic.
And then the other side is catabolic,
Catabolic.
right? Okay, I wrote it wrong in my notes.
This way.
I wasn't
Yeah.
understanding.
Anytime you go from large to small,
Yes.
it's catabolic.
Mm-hmm.
Small to large,
Anabolic.
this is a big, there's a macromolecule. If we went from glucose up to glycogen, that's a macromolecule. And the lipid is kind of an in-between size molecule. Not as big as the other.
Yeah,
Think
no,
of
I
Anna
I
as
wrote it
adding.
wrong in my notes.
Anna adding.
Mm-hmm. You taught me that.
Oh.
Mm-hmm.
Now there was a question with my study group this morning because of their SI yesterday or something. On the feedback inhibition, you wrote, you know, reactant A, B, C, D, etc. And then those reactants are because somebody had it that apparently SI wrote that those globs were not the enzymes, and I said no, those are the enzymes because you have your active site in the enzyme and you have your allosteric site in the enzyme. Am I correct?
Let's talk about feedback inhibition. I want to try to probe exactly what your question is. So the way I draw this is we have an anabolic pathway, a synthetic pathway, right?
Mm-hmm.
And we're going to make a compound, let's say compound E. So we have A, enzyme 1, makes B, enzyme 2, makes C, enzyme 3, makes D, enzyme 4, makes E. So the goal of this pathway is really to convert A to E. The cell needs some E. But then we would imagine, and maybe E is an amino acid like tryptophan, some amino acid that we need to use. Let's imagine now that the person finds a free source of E in the diet. We happen to have a dietary source of lots of E, and we have it for free, and we have it in excess. Should this pathway continue to proceed in spite of the fact that we might use up ATP to make E? Active site, right?
Right.
Mm-hmm.
But in the presence of excess E, the enzyme will change its shape. E now can fit into the allosteric site, and look what happens. My E is sitting there. This is the enzyme, same primary structure, but three-dimensional structure is different. And what happened to my active site? It's pinched.
Yeah.
Can A fit?
No.
It can't fit in, so this enzyme is blocked. But it's totally reversible, isn't it? So that when I use up my excess E, the enzyme is so smart, it realizes instantly, we're out of E, I have to go back to this shape now, start here, and let her rip. So that's feedback inhibition.
Okay, I understood it right. That's
Good.
what I wanted to make sure.
Yeah.
So how do you stay so skinny?
How did I stay so skinny? Okay, I'll tell you. When I was,
Life makes
when I was
sense.
30, no,
Starves.
when I was 39, I started getting this nice beer belly.
No.
And I went on this, I thought, well, I'm going to do cardiovascular workout as a regular part of my life. That's a long time ago. And so that helped. Then I eliminated the alcoholic beverages about 12 years ago. That helped a lot. And then about 12 years ago, I started doing strength training as a part of it as well, which is really critical when you get old. Because when you get old, your muscles atrophy. So then you can't be as physically strong. And so a lot of this is due to my teaching this class. Because I've read a lot of research. I started teaching this 20 years ago. 21 years ago now. And everywhere I turn, I read about the benefits of cardiovascular exercise as well as strength training, not just on the one system, but on many systems and on the overall health. So that is how I attribute it. It's a lifestyle change. I'm a big proponent of lifetime fitness, very big proponent of it. And I'm almost 64, but I can still keep up. And I think that's why. I mean, just the most recent, I just read one last week, I'll tell you about it. Our chromosomes look like this. The ends have these things called telomeres on them. And they analyzed the telomeres of young people who were couch potatoes and young people who were active, and old people who were couch potatoes and old people who were physically active. And what they found was that people who were very active had long telomeres, which means that you have this protective area on the ends of your chromosomes. So you have young chromosomes, if you will, as opposed to older chromosomes. So our telomeres erode as we get older. Well, exercise reduces or prevents a lot of that erosion of the telomeres. And once the telomeres have eroded away, now every time the cell divides, you lose important information on the chromosome. And that cell is dead. So you want to keep, one of the reasons why Dolly, the cloned sheep, did not do well, in fact all cloned mammals so far have shortened telomeres, because they are clones of an adult. And so they're receiving, at the day they're born, they already have shortened telomeres, which look like an older animal. So although they're young, in terms of their actual years on Earth, they have these older telomeres, which put them at a disadvantage. And most of these cloned animals have shorter lifespans. So maybe we should put them on treadmills.
Is that reversible?
That's a good question. We haven't gotten there yet, but so you folks are all pretty young. You can still, change your lifestyle and make a difference. Part of it's diet too. I do watch my diet to some certain extent. But I'm a firm believer in a regular, I have my own big room, which is my gym. And the Temple of Doom is what I call it. But that's the short answer to that, the long answer to that.